So this is problem 20 of chapter 9 of Giancoli 6th edition. This problem is very similar to the one that we solved in class. The only difference now is that the cord that holds this beam is not at the edge. Okay, so what is the drawing? We have here a wall, a big wall. We have this cord attached to it, and this cord is holding a beam. Okay, so this is the beam. At the edge of this beam, we are holding a big sign, and we know the mass and we know the weight of this big sign. Okay, we know the distance from this big sign, or the size of this whole beam, which is 1.70 meters. And now this distance between the edge, the wall, and the point where the cord touches the beam is also given to us, is 1.35 meters. And we have this angle. Okay, this angle is 35 degrees. Very well. We know the weight of this sign. We also know the weight of this uniform beam, and we know that the weight of this uniform beam should be right at the middle of the beam, somewhere here. Okay, 1.7 divided by 2. Okay, all right. So what other forces do we have? Well, we have the force along the cord. It's a tension force, and the tension force is always along the cord, so here it is, Ft. What else do we have? Well, we have, let's put the mg for the sign here, right? And what else do we have? We have the weight on the hinge. So this beam is attached to the wall on this hinge. The problem with the force on the hinge is that we do not know exactly what its direction is. I'm just going to put it like this. So I have an x and a y component, and we are going to try to find this x and y component. So I'll call this the FH. What the problem is really asking us is this component here, the FHX, and this component here, the FHY. Okay, so these are all our unknowns, the FHX, the FHY, and also the FT. All right, how are we going to solve this problem? Sum of all the forces in the x direction is 0. Sum of all the forces in the y direction is 0. Sum of all the torques is 0. So these are the conditions for equilibrium. So I'm going to start with the x direction. So what do we have in the x direction? Well, that force that we don't know, that we want to find, the FHX. And what else? We have the FT. Ft cosine of 35 degrees. So cannot do anything with this equation, have two unknowns. Let's move to so these are the equations in the x direction. Let's move to the sum of the forces in the y direction. So what do we have there? Well, we have the FHY that we do not know. I'm going to call positive going up. Okay. We also have the FT, so plus FT sine of 35 degrees, and the weights pointing down. So we have here the weight of the beam, and we have the weight of the sign. All this equal to 0. Okay, again, we cannot solve because we have two unknowns. Let's go now for the torque. And let's choose a convenient point as our axis of rotation. So I'm going to choose that right where the hinge is. So I do not need to worry about those forces right on the hinge. So I'm going to choose this point here as the axis of rotation. Very good. So what are the torques? Oh, well, we have the weight of the beam trying to move it clockwise, so negative. So here is the sum of all the torques, but we have minus mg, and the distance from the axis of rotation, which is the 1.70 divided by 2. This is a uniform beam, so its weight is right on the middle. What else do we have? Well, we also have the weight of the sign, so minus big mg, and the whole distance 1.7. Minus again because it's trying to rotate it clockwise. Now the tension force, the y component of the tension force, is trying to rotate counterclockwise, so this will be positive. So plus Ft sine of 35 and the distance which was given to us 1.35. All this equals to 0. So from here now we can find Ft. So one unknown is done. Then from there we can find Fhx and Fhy. So this is the end of the problem.